Good afternoon, good morning, and thanks for joining us today. The title of my talk is The Current Status of the Most Dominant SARS-CoV-2 Variant. And I'll dive back, but right back in by trying to frame the question, which is a little more complicated than you might think from the title. Because the question of what is the most dominant SARS-CoV-2 variant really depends on when and where you look, and I'll try to explain what I mean in the next couple of slides. This slide, which includes a schematic taken from our world in data, is the first way in which you can look at this. And it looks at the SARS-CoV-2 variants over time from May 2020 to November 2022, and defines each of the variants of SARS-CoV-2 that emerged during the course of the pandemic, highlighting each of them as a frequency of all the SARS-CoV-2 variants that we have in the sequences that we've analyzed as a community looking over time. And what you can see is the emergence and subsequent waning of each of the different variants over time. If you take a step back and actually just focus really even on the last year, you can see that even within that time frame, it's quite difficult to define what the most dominant SARS-CoV-2 variant is. We saw as Omicron emerged, we saw the emergence of Omicron BA1, that beige color, and that was rapidly replaced by an emerging sublineage of Omicron called BA2, in turn replaced by Omicron BA5, which is that blue color, and which still accounts for almost half of global SARS-CoV-2 infections currently. But you can also see that that salmon color, Omicron BQ1, which is a relatively new sublineage of the Omicron sublineages, of which there are now many, now accounts for just under 50% of SARS-CoV-2 infections. And within the smaller sub-fractions of all of these different colors, you can see lots of other versions of Omicron that are starting to be detected. And these are the most common ones. These are the ones that we can see, naked eye looking at this kind of schematic, but there are more than 500 different versions of Omicron that have been detected. And really, if you look deep enough within any set of SARS-CoV-2 sequences, you can pick up innumerable versions of SARS-CoV-2. So it's becoming increasingly complicated to understand the level of diversity that exists. And that was taking a global view of the variation that occurs within the SARS-CoV-2 variants that circulate across the globe. If you look by country, you'll see the patterns are somewhat different. Again, this is now breaking down the SARS-CoV-2 variants that are currently circulating as of this time frame. This is sequence data again from our world in data in November the 21st, broken down by country. And again, the different colors here indicate the different Omicron sublineages. And you can see that, again, the most common dominant variant varies by country. In South Africa, where I'm from, you can see that almost 90% of our infections are still caused by Omicron BA5. That's the dark blue color. But the situation in Australia is very different. In Australia, under half of infections are caused currently by Omicron BA5. Quite a number of infections there caused by Omicron BA2.75 and a substantial portion by Omicron BQ1. If you look at the situation in Europe, you can see there's a significant shift again in the colours that you're seeing here, with somewhere between 40% and 80%, depending on the country, of infections currently caused by Omicron BA5. But an emerging and quite significant in some countries proportion of infections caused by Omicron BQ1. So again, it depends on what is the most dominant variant in the country that we happen to be studying. If you look in Canada and the US, at the moment, and this may have changed in 2 weeks' time when this recorded talk is presented, at the moment, half of infections are caused by Omicron BA5, but an increasing proportion of infections are caused by BQ1. So it's not as simple as you might think to say what is the most dominant variant of SARS-CoV-2 at any given point in any given place. It's also very difficult to predict whether a given variant is going to sweep across the world or not. We as a community, we anxiously watch the sequences of SARS-CoV-2, and we try to predict whether a variant that's detected in the sequencing data is going to be a problem or not. And we've become quite good at spotting mutations, and we have a pretty good handle now on mutations that might represent a risk, but it's very difficult to predict whether a variant that we spot in the sequencing data is actually going to sweep across the world or not, and many of them do not. Many sublineages or many sequences that we pick up in the sequencing data don't actually take off. BA.4/5, as you know, was first detected in South Africa and did sweep across the world very rapidly. But it's very difficult, as I said, to predict whether one will, and it's affected by many, many factors. These include the transmissibility of the variant, the severity of the disease, how many spikes are incorporated into a variant. But what's a major factor, and one which we do tend to focus on very much in our analyses of emerging variants, and one which I'll speak about a lot today, is how neutralization resistant a variant is. And this is something that we focused on very much when we picked up BA.4/5. I use the words BA.4/5 interchangeably because they have the same spike sequence, and watched it as it swept across the world. We know very well now that BA.5 has high level of resistance to neutralizing antibodies. There have been many, many studies that have come up from across the world, and I'm showing you just a couple here that show that this version of Omicron is extremely resistant to neutralization. And this is data showing BA.4/5 in green at the end of each of these graphs, showing its high level of neutralization resistance to people whose sera was obtained after they received either an AstraZeneca vaccine or a Pfizer vaccine. And the same has been shown for people who received any of the vaccines that are available. This version of Omicron is highly neutralization resistant. And that would explain why you might expect to see high levels of breakthrough infections, even in countries where there is high level deployment of vaccines. It also explains why we see high levels of resistance of BA.4/5 to monoclonal antibodies. And that's what's shown in this slide here. You can see BA.4/5 at the end here, in general, is very, very resistant to all the therapeutically relevant monoclonal antibodies. And so all of that would explain why a variant such as BA.4/5, and I'll speak about some of the other variants that are also neutralization resistant and are also of relevance currently, why that might become a problem as it emerges and starts to spread across the world. But the other thing that really matters is the context, the immune context in which a new variant is emerging. And I'll use again BA.4/5 here as an example. In South Africa, BA.4/5 was detected right on the heels of a massive wave of infections caused by BA.1. And so you might hypothesize that following such a wave of infections caused by BA.1, the only way in which BA.4/5 might be able to spread is if the antibodies that were triggered by this huge wave of BA.1 infections were not very effective against that emerging BA.4/5 variant. And that, in fact, turns out to be exactly what happened. We showed that in the study by studying a group of people in South Africa who were hospitalized with BA.1 infections. And we studied their immune response to BA.1 and showed that they actually mounted very good neutralizing antibody responses to BA.1 infection. So if you were infected with BA.1, you made very good neutralizing antibody responses to BA.1. But the question was, how good would your antibody responses be to BA.4 or BA.5? And the answer was not very good. That's this data shown right here at the end. So although you made neutralizing antibody responses up in 1 in 3,000 level, very high titer responses to BA.1, your neutralizing response to BA.4/5 was very low. And that provides sort of an immunological mechanism for why an emerging variant like BA.4/5 was able to take off and spread in the context of a huge prior wave of infections by BA.1. So what I'm trying to explain using this set of data is why, even in the context of high levels of prior infection, the immune context matters. The immune exposure that the population has, to some extent, determines whether a variant gets a toehold and is able to take off from that population. What about the other variants that are now getting that toehold, taking off in Australia and Europe and the US? Well, in some part, that ability that they have to take off is also conferred by the fact that they are extremely neutralization resistant. We spoke in some of my earlier slides about BQ1 and BA2.75, which are taking off to some extent in Europe, the US, and Australia. And in some parts, as I'll show you on the next couple of slides, that is because they too are extremely resistant to neutralization. This is data from the Karolinska Institute, from Daniel Schmidt and Ben Morrell, that shows the extreme neutralization resistance of BA2.75 down here, and 2.75.2, which is a slightly more mutated version of BA2.75. And you can see, compared even to BA5, which we consider to be highly neutralization resistant, there's an even further drop in neutralization sensitivity in these more resistant variants. Again, as these emerging variants pick up more and more mutations, they become increasingly resistant to neutralization. And that's why, even in the context of high levels of infection and vaccination, they are able to continue to spread. And it's also why they are able to show high levels of resistance to monoclonal antibodies, to almost all the classes of monoclonal antibodies that we now have at our disposal for treatment. The same is true for BQ1 and BQ1.1, both of which are now showing a strong ability to spread, even in the context of high levels of prior infection and high levels of vaccine deployment in many countries, again, through their strong ability to resist neutralization. And that too here is shown in a preprint recently published that shows the really high ability of these sublineages to resist neutralization in healthcare workers who receive 3 doses of vaccination. So these variants of Omicron and their offspring, for lack of a better word, are really incredibly resistant to neutralization. But it's really important, it's very easy to focus on the high level of neutralization resistance that these variants have, but very important to remember. In South Africa and in much of the rest of the world, these variants, however neutralization resistant they are emerging in the context of people who have high levels of seropositivity. This is an example from my country where we've experienced these 4 major waves caused by four variants. And many studies in blood donors across my country have shown that virtually everybody in my country have either been vaccinated or infected. And so virtually everybody has some level of immunity to SARS-CoV-2. And actually, it's more than just everybody has some level of immunity. Probably we are entering a period where we have a very complex level of hybrid immunity, where people have been infected and vaccinated and reinfected and possibly vaccinated twice and received more than one type of vaccine. And so almost everybody, in most, not all, but most parts of the world, have high levels of hybrid immunity where our immune responses have had time to mature and develop. And really, we have quite a significant level of immunity to SARS-CoV-2 infection and vaccination that will enable us to deal quite well now with most SARS-CoV-2 variants. That may not prevent us from becoming reinfected. I think the notion of preventing reinfection is becoming increasingly difficult, but will nonetheless prevent severe disease. And I'm speaking only about antibodies without getting into T cells and FC effector function, which we all know are very good at preventing severe disease. And this is why we've seen this decoupling of infections and hospitalizations. We've seen lots of infections, but many fewer hospitalizations and deaths. This was first reported here in South Africa and is now a global phenomenon, which is reassuring as we watch these highly neutralization-resistant variants emerge across the world. So we are seeing new variants continue to emerge, and there's local variation in which variant dominates. That local variation is difficult to predict. We continue to try to do so, but it is difficult to predict and may be related to prior immune histories as well as to intrinsic virological factors. Most of these emerging variants do show high levels of neutralization yet, and that compromises monoclonal antibody treatments and may necessitate the need for new monoclonal antibody treatments, and certainly necessitates new vaccine strategies. Going forward for pan-coronavirus type strategies that will deal with emerging variants, as well as for new zoonotic threats that continue to plague us. But population immunity is extremely high in most countries, and T cells are non-neutralizing antibodies, so if you remain resilient against emerging variants. So and that will continue to reduce the severity of clinical outcomes. So though these variants of concern they can seem extremely alarming, I think perhaps we're in a better space than can be imagined looking at sequences in many cases. And with that, I'll end and thank the many people I work with in my laboratory for their hard work over the last 2 years. Thank you.